Imagine a machine so complex that it can help print patterns smaller than a wavelength of visible light. A machine that does not design AI chips, does not manufacture the final chips, and does not make smartphones or computers. Yet without its technology, producing the most advanced generations of chips would be far more difficult. This company is called ASML. Based in the Netherlands, ASML makes advanced lithography systems used by chip manufacturers around the world. Its machines use light to print incredibly tiny patterns onto silicon wafers, patterns that eventually become part of the circuits inside modern microchips. The technology is so advanced that ASML became the only company capable of producing EUV lithography systems, a technology used to print the most intricate layers of some of the world's most advanced chips. And the story becomes even more surprising. ASML was not born as a global technology giant. It began in 1984 as a joint venture between Philips and ASM International. From those humble beginnings, the company spent decades solving problems that once seemed almost impossible. So how did a small Dutch company become one of the most important technology companies in the world? And what makes its machines so difficult to build? This is the story of ASML. What exactly does an SML do? Most people know NVIDIA. Many know Apple, AMD, and TSMC. But very few people know ASML. Yet ASML plays a critical role in the manufacturing of some of the world's most advanced computer chips. So, what exactly does this company do? ASML does not design NVIDIA's AI chips. It does not manufacture the final chips either. Instead, it builds highly advanced lithography systems used by semiconductor manufacturers. Think of lithography as an incredibly precise form of printing. But instead of printing ink on paper, these systems use light to transfer microscopic patterns onto silicon wafers. Those patterns help create the complex structures inside modern computer chips. The smaller and more precise these patterns become, the more advanced the chip can potentially be. This is why lithography is so important. Companies such as TSMC, Samsung, and Intel use advanced manufacturing equipment as part of their chip production processes. And ASML is one of the most important companies supplying this technology. But ASML's machines are not ordinary industrial equipment. They combine advanced optics, precision engineering, software, and powerful light technology. And the most difficult challenge was still ahead. How do you create light powerful and precise enough to print the tiniest patterns needed for the next generation of chips? To answer that question, ASML had to help develop a technology that once seemed almost impossible: the problem with making chips smaller. For decades, the semiconductor industry followed one powerful idea: make the components smaller and put more of them onto each chip. This allowed computers to become faster, smartphones to become more powerful, and AI systems to process more information. But making smaller chips created a serious problem. A chip's design must be transferred onto a silicon wafer with incredible precision. One way to think about this process is like using a stencil. Light passes through a carefully designed pattern and helps create the shape of a circuit on the wafer. But there is a limit. The smaller the pattern needs to be, the more difficult it becomes for the light to reproduce that pattern accurately. So engineers needed a way to use shorter wavelengths of light. Shorter wavelengths can help create smaller features. This led the industry toward extreme ultraviolet lithography, known as EUV. EUV uses light with a wavelength of 13.5 nanometers. But creating and controlling EUV light is extremely difficult. The light is absorbed by air. The mirrors must be extraordinarily precise, and the entire system must work with incredible accuracy. For ASML, solving this problem would require years of research and cooperation with companies around the world. But first, engineers had to solve the most basic question. How do you create EUV light in the first place? How do you create EUV light? The answer sounds almost impossible. Inside ASML's EUV system, a tiny droplet of molten tin is released into a vacuum chamber. Then a powerful laser hits that droplet. The laser pulse turns the tin into a hot plasma. That plasma produces extreme ultraviolet light. But creating the light is only the beginning. The EUV light must then be collected and directed through the machine. And ordinary lenses cannot be used. Why? Because EUV light is absorbed by materials that normal light can pass through. It is also absorbed by air. So the system must operate in a vacuum. Instead of ordinary lenses, the machine uses specially designed mirrors. These mirrors are incredibly precise. Even tiny imperfections can affect the light and reduce the system's performance. The light then travels through the optical system before reaching the silicon wafer. This entire process happens inside one of the most complex machines ever built. And every part must work together with extraordinary precision. The laser, the tin droplets, the vacuum, the mirrors, and the software. If even one critical part fails, the entire process can be affected. But there was another massive challenge. ASML could not build this technology alone. To make EUV practical, it needed help from a global network of highly specialized companies, the global team behind one machine. ASML could not build an EUV system by itself. The machine is so complex that it depends on technology from a vast network of specialized suppliers. One company develops the powerful laser system. Another specializes in the precision mirrors needed to control EUV light. Other suppliers provide highly specialized components, sensors, software, and mechanical systems. ASML brings these technologies together into one integrated lithography system. This is one of the most important parts of this story. The machine is not simply a product assembled from ordinary parts. Every major component must work together with extraordinary precision. And developing those components took years of research and engineering. Some suppliers have spent decades building expertise in their specific technologies. This created a network that is extremely difficult for competitors to reproduce. ASML also worked with research institutions and semiconductor companies during the long development of EUV technology. The result was a global engineering ecosystem focused on solving one incredibly difficult problem. How do you make EUV lithography work reliably in a real semiconductor factory? After years of research and development, the technology finally began moving from scientific experiment to industrial production. And once EUV systems became practical, ASML's position in the semiconductor industry changed dramatically. But building the machine was only half the challenge. The next question was even more important. Could chip manufacturers actually use this technology to produce advanced chips at scale? When you finally reached chip factories, After years of research and development, EUV technology began moving from the laboratory into real semiconductor manufacturing. But creating the technology was not enough. Chip manufacturers needed to use it reliably in factories producing millions of advanced chips. That required enormous investment, highly trained engineers, and extremely complex manufacturing processes. When EUV systems began entering high-volume semiconductor production, they became an important tool for creating some of the most advanced chip technologies. The basic idea was powerful. Using shorter wavelength EUV light could help manufacturers print extremely small patterns on silicon wafers. This gave chipmakers another tool for continuing to develop more advanced semiconductor technologies. Companies such as TSMC, Samsung, and Intel became important customers in the advanced lithography industry. But the relationship between ASML and chipmakers is not as simple as buying a machine and switching it on. Each system must be installed, calibrated, and integrated into a highly complex semiconductor factory. The machines also require advanced software, maintenance, and technical support. That is one reason ASML's business is so difficult to copy. Its advantage is not just one machine. It is the result of decades of research, specialized suppliers, engineering knowledge, and close relationships with the world's leading chip manufacturers. And this created something extraordinary. A company that does not make the final chip became essential to the process of making some of the world's most advanced chips. The company behind the future of chips. Today, ASML occupies a unique position in the semiconductor industry. It does not design the AI chips inside NVIDIA's data centers. It does not manufacture the final processors. And it does not sell smartphones or computers. Instead, ASML builds some of the most advanced lithography systems used in semiconductor manufacturing. Its EUV technology is used for the most intricate layers of certain advanced chips. That makes ASML a critical part of the technology supply chain behind modern computing. But the company's real advantage was not created overnight. It came from decades of research, thousands of engineers, a global network of specialized suppliers, and billions of dollars invested in solving problems that once seemed almost impossible. The story of ASML reveals something important about the technology industry. The companies that change the world are not always the companies consumers see every day. Sometimes the most important company is the one building the technology that makes everything else possible. NVIDIA designs powerful AI chips. TSMC manufactures many of the world's most advanced chips. And ASML builds the lithography systems that help make some of those advanced chips possible. Together, these companies represent a hidden chain behind the AI revolution. And at one critical point in that chain, you will find ASML, a company most people had never heard of until the world began to realize just how important its machines really were. If you enjoyed this documentary, subscribe to Inside Horizon for more stories about the companies, technologies, and hidden systems shaping the future. Thanks for watching.